Hi, sir. Welcome to our presentation. Uh, the topic is echelon form. My roll number is 21951A1227. My name is V. Gautam. What is echelon form? Uh, Echelon is a military term that refers to a specific type of formation in echelon form. Each member of the formation is positioned behind either right or left of the member ahead. Echelon form of a matrix. Echelon form of a matrix. In this, we have 3 points. What does it mean of a matrix in the echelon form? What we need to pay attention to the leading entry in a row. The leading entry of a row, first row non-zero entry in the row, and the next in this we have matrix. Echelon form of a matrix. Consider this matrix 0, 0, 0, all zeros and 1, 8. With the -1, 2, 5, -7, 0, 0, all zeros and 0, 0, 3, 0, 6. And next, echelon form of a matrix. In this we have 3 points. Any rows of all zeros are given are below any other non-zeros rows. And second point is each leading entry of a row in a column to the right of a leading entry of the row above it. And next third point, all entries in a column below leading entry are zeros. The next point is in this we have 3 points also. Uh, any rows of all zeros are below any other non-zero rows. And the next second is each leading entry of a form row is a column to the right of a leading entry of the row above it. And the next third is all entries in a column below leading entry are zeros. You can see the here all zeros in the last one. And the next is reduce the echelon form. We say that a matrix is in reduced echelon form if it is in echelon form, and additionally the fourth point, the leading entry in each non-zero row is 1, and the fifth one is each leading one is only non-zero entry in its column. And next is reduce the echelon form. In this we have 5 points. First point, rows of the zeros at the bottom, and second is leading entries go down and to the right, and next third is zeros below leading entries, and the fourth every leading entry is 1, and fifth is zeros above the below leading entry. And next, uniqueness of a reduced echelon form. In this we have 2 points. We can transform any matrix into a matrix in reduced echelon form using elementary row operations. And the next is, however, no matter what sequence of the row operations we use, each echelon, each matrix is row equivalent one of only one reduced echelon matrix. And the next is using row reduction. In the next video, we will learn how to use elementary row operations, how to find unique echelon form, and then how to then use that form obtain the solution of the system linear equations. And the next in this linear algebra, a matrix is an echelon form that is shaped resulting in Gaussian elimination in a matrix. A matrix being in a row echelon form means that the Gaussian elimination that has operated on the rows, and the echelon forms mean a Gaussian elimination has operated on the columns in other keywords. In other words, a matrix is in column echelon form, is in transpose, is in the row echelon form. Therefore, only row echelon forms consider the remainder of this article. These similar properties of a echelon form echelon form are easily deduced by transposing of all the matrices. Especially a matrix is in the row echelon form of it. And the next in this we have 2 points. All rows consisting of only zeros at the bottom. And the next is the leading coefficient, also called pivot of a non-zero row, is also strictly to the right of the left leading coefficient of the row about it. Some texts add the condition that the leading coefficient must be 1. These two conditions imply that all entries column below that leading coefficient are zeros. And the next is a matrix is in reduced row echelon form, also called as row canonical form. If it satisfy the conditions, in this we have three conditions. It is in row echelon form, and second one is the leading entry is in each non-zero row is a one called is leading one. Each column containing a leading one has zeros in its other countries. And the next is the reduced row echelon form of a matrix by computed by Gauss-Jordan elimination. Unlike the row echelon form is reduced by echelon of a matrix. This uniquely does not depend on the algorithm used to compute it for a given matrix disappeared for the row echelon form. Not being unique, all row echelon forms the reduced row echelon form have same number of zero rows and points are located in the same incidence. And systems of linear equations. The system of linear equations is said to be a row echelon form, which is augmented matrix is in the echelon form. Similarly, a system of linear equations is said to be reduced row echelon form or canonical form. This augmented matrix is reduced the row echelon form. And the next, the canonical form is viewed as explicit solutions of the linear system. And the fact the system of the constant is only is only is only if the equations of the canonical form is reduced to the 0 equal to 1. Otherwise, regrouping in the left hand side of the terms of the equation, but the leading ones is expression variable corresponding to the pivots constants of the linear equations of the other variables, if any. And the next is many of the problems you will solve in the linear algebra requiring of the matrix converted into the one of the two forms and the row echelon form. It is strictly variant reduced row echelon form. These two forms will help you see the structure what the matrix represent in the if the matrix represent the system of the linear equations. These forms allow the write the solution systems. Every computer algebra systems of the most scientific or graphing calculators have commands which produce this forms of any matrix. These commands are often of the reverse view. The row echelon form. A triangular matrix is in row echelon form. It has the following three properties. All non-zero rows are above rows of the zeros. Each leading entry of the row of a row is in the column to the right of the leading entry row about it. And next third one is all entry of the column below a leading entry of are zeros. And next, what is a row echelon form? A matrix is in the row echelon form if it meets the following requirement. The first non-zero number from the left, the leading coefficient is always right of the first non-zero number in the row above the rows consisting of all zeros are at the bottom of the matrix. A rectangular matrix of the is in the row echelon form. It has the following three properties. All non-zero rows are above rows of the all zeros. Each leading entry of a row is in the column right of the leading entry of the row about it. The all entries in the column leading in the zeros. And the next is the row echelon form. Column in echelon form of the matrix is important because it is lets you easily determine if the system linear equations corresponding if the to the augmented matrix is solvable. These observations form the motivation behind this method to solve the solve systems of linear equations known as Gaussian elimination, named after a inventor Karl Friedrich 1977 and 1855 from Germany. What is echelon effect? If there is a regular structure similar to the flight of stairs at railways in the halls, sound produced in front of such a structure may produce the musical note due to the regular successive echoes sound receiving observers such as effect is echelon effect. What is echelon form of the matrix example? A matrix is in the echelon form. It has three properties. All non-zero rows are above any rows of the zeros is leading the entry column right to the leading of the entry above it all entries column below leading entries are the zero. A group of individuals at a particular level or grade in an organization or field activity, the upper echelons of the management echelon work echelons. Thank you.